One of the most prestigious and valuable gems in the collector world right now carries a legendary designation tied to a specific vivid red fluorescence that only certain Burmese stones naturally exhibit.
Yeah, and it's a geological anomaly, so staggering, and honestly a market phenomenon, so disconnected from how we normally value physical goods that it's forcing institutional investors to completely rewrite their playbooks, for wealth preservation.
We are diving straight into the deep end today. Welcome to the deep dive, by the way.
Yeah.
Our mission today is to dissect the absolute pinnacle of the colored gemstone market, which is, of course, the Burmese ruby.
Right.
Because for centuries, this singular red stone captivated ancient monarchs. It sparked all this wild folklore. But today, it has captured the attention of modern billionaires, sovereign wealth funds, and serious institutional buyers looking for an unshakable store of value.
Absolutely.
So we're going to figure out the mechanisms driving this obsession for you.
And to map out this terrain, we've pulled together an incredibly diverse stack of source materials for you today. I mean, we're looking at dense, highly technical geological surveys that map out the exact subterranean conditions.
They're intense, by the way.
Oh, incredibly intense. The exact conditions required to form these specific crystals. And we're pairing those with the internal, incredibly strict gemological laboratory grading standards from the world's most elite institutions. So GRS, Gubelin, SSF, and the GIA.
Right.
And then to see how all of this translates into actual human behavior, we have the latest auction house records from Sotheby's and Christie's, alongside some, honestly, very sobering 2026 market valuation reports.
So here is the big tease, the core premise we're going to test today. We're going to unpack why a hyper-specific combination of ancient tectonic collisions and sheer, almost freakish chemical purity has created a verifiable 10 times multiplier in value for rubies coming from one tiny remote valley in Myanmar.
Yeah, it's wild.
It's a convergence of factors that has effectively crowned these specific, untreated rubies as the hardest asset of the decade in 2026.
And, you know, the term hard asset gets thrown around a lot in financial circles, usually referring to real estate, gold, or art.
Sure.
But the data in these 2026 valuation reports suggests the top-tier Burmese ruby represents a form of concentrated wealth that operates in a league of its own completely.
Right. But to grasp the economics of today, we actually have to abandon the auction house entirely for a minute.
We do, because the premium we see on paper is fundamentally anchored in a geological event that occurred roughly 50 million years ago.
50 million years. So we're going back to the Himalayan orogeny, and I remember reading about this in high school earth science. But the scale of it's just hard to wrap your head around.
It really is.
We are talking about the Indian tectonic plate colliding head-on with the Asian tectonic plate.
Yeah, it is arguably the most dramatic geological event in the recent history of our planet. Two colossal continental land masses moving toward each other, inevitably slamming together.
Right.
But the crucial detail for our ruby story isn't just the continents themselves. It's what was trapped between them. Because before the collision, a vast body of water called the Tethys Ocean separated India and Asia.
A completely lost ocean.
Exactly.
And the floor of that ocean would have been covered in sediment, right?
Right.
Like millions of years of marine life dying, their shells and skeletons drifting to the bottom, compressing into rock.
Precisely what geologists call platform carbonates, though we know it more commonly as limestone.
Okay, limestone.
Right. And as the Indian plate ground into the Asian plate, the immense forces didn't just push rock upward to create the Himalayan mountains, it also folded the earth downward.
Oh, wow.
Yeah, that ancient sediment-rich seabed of the Tethys Ocean was caught in the crush and thrust deep into the Earth's crust.
I'm trying to picture the sheer violence of that. I mean, you have an ocean floor being swallowed and buried under miles of continental crust. The friction and the weight involved must have generated an unimaginable environment.
Well, the geological surveys put specific numbers to it, and they are extreme. As this limestone was pushed deeper, the ambient pressure skyrocketed, and it was essentially baked. Baked. The surveys indicate this limestone was subjected to sustained temperatures between 11,112 degrees and 1,238 degrees Fahrenheit.
That is intense.
And when you apply that level of heat and pressure to sedimentary limestone, you trigger a metamorphic change. The rock physically transforms into calcite dolomite marble.
Okay, which brings us to the first massive filter in our geological lottery. Why does it matter that the limestone turned into marble?
Because of what that original limestone was made of, or, well, more importantly, what it lacked.
Ah, I
Because it was formed from marine biology in a platform ocean environment, it was exceptionally poor in iron, and iron is one of the most abundant elements in the Earth's crust.
Right, it's everywhere.
Everywhere. And it ruins the optical properties of most gemstones. But this newly formed, deeply buried marble was a pristine, iron-free sanctuary.
But a clean sanctuary doesn't spontaneously generate a gemstone, right? I mean, you still need the ingredients for a ruby. You need aluminum, and you need a coloring agent.
Exactly.
So where did those come from if the marble is essentially a blank slate?
This is where the timing of the tectonic event becomes critical. While the marble was being cooked, the broader collision was also causing extreme tectonic fracturing.
Okay.
And this fracturing allowed molten magmas, specifically granite and syenite magmas, to intrude into the marble layers.
Now, syenite magma is a term that might be new to a lot of people.
Yeah?
How does it differ from, the typical lava we see erupting from a volcano?
Good question. Syenite is a coarse-grained, intrusive igneous rock. The key characteristic here is that it's rich in alkali metals and aluminum, and it forms deep underground, cooling very, very slowly.
Right.
So as these intrusions of molten rock forced their way into the surrounding marble, they initiated what geologists call a skarn reaction.
So it's like a chemical exchange zone where the magma meets the marble.
That is the perfect way to visualize it. As the magma slowly cooled, it expelled these superheated, mineral-rich hydrothermal fluids.
Wow.
And these fluids acted as a delivery system. They migrated through the microscopic fractures in the iron-free marble, carrying heavy concentrations of aluminum and, crucially, a trace element called chromium.
Okay, let's unpack this.
Yeah.
It's like baking a cake where the oven is a colliding continent, and the baking pan has been scrubbed completely clean of iron, allowing only the purest red ingredients to rise.
That's a great analogy, yeah.
So the magma provides the delivery trucks full of raw materials, and the marble provides a sterile, iron-free factory floor. But if iron is so common in the Earth's crust, just how rare is this clean marble environment compared to other ruby sources?
The rarity is just staggering. If we connect this to the bigger picture, you have to consider the alternative. A vast majority of the world's rubies, especially those historically mined in places like Thailand, Cambodia, or even parts of Africa, are basalt-hosted.
Meaning they form in volcanoes.
Right, they form in volcanic environments, and basaltic rock is inherently rich in iron. So when corundum crystallizes in those environments, the growing gem acts like a sponge, absorbing significant amounts of iron from the surrounding rock.
Ah, so the environment essentially pollutes the crystal.
Inherently, yes. But the marble-hosted deposits of the Mogok Stone Tract, which, by the way, is an incredibly small, isolated valley in Myanmar, covering only about 400 square kilometers, avoided that fate.
400 square kilometers. That is tiny.
Exactly. The tectonic isolation of that Tethys-ocean limestone created a true geological singularity. It is the holy grail of ruby formation because it's an environment that naturally systemically excluded iron while providing abundant chromium.
Which brings us to the real payoff of this geological lottery. Because the Mogok Valley successfully locked iron out of the crystal structure 50 million years ago, it unlocked a total freak of optical physics that we can observe today.
Yes.
So we need to talk about the visual hallmark of a Burmese ruby, what the trade famously calls the Mogok glow.
And the glow isn't just some marketing term, It's a measurable quantum mechanical phenomenon.
Really?
Oh, yeah. To grasp it, we have to look at the crystal lattice of corundum. In its pure state, corundum is composed entirely of aluminum and oxygen. It is completely colorless. I mean, white sapphire is just pure corundum.
Right. So the ruby needs an impurity to become red.
Yes, the color relies on substitution. In a ruby, a tiny fraction of the aluminum atoms in the crystal lattice are replaced by chromium atoms, specifically chromium 3 plus Pri.
Okay.
The chromium absorbs certain wavelengths of white light, primarily in the yellow and green spectrum, and transmits red light back to our eyes.
But just transmitting red light just gives you a red stone, right? I mean, plenty of garnets or spinels are red. The sources emphasize a specific interaction with ultraviolet light.
Right, and this is where chromium elevates the stone from eerily colored to actively luminescent.
Luminescent.
Yes. Natural sunlight contains a significant amount of ultraviolet, or UV, light. When those invisible UV photons enter the ruby, they strike the chromium atoms. The energy from the UV light excites the electrons in the chromium, bumping them up to a higher energy state.
But they can't stay in that excited state forever, obviously.
It cannot. Almost immediately, those electrons drop back down to their ground state, and when they drop, they have to release that absorbed energy.
Oh.
They release it in the form of visible red photons. This process is called chromium fluorescence.
Wow. So the stone is literally taking invisible light from the sun, converting it, and beaming visible red light out of the crystal. It is glowing in broad daylight.
Actively emitting light. It's wild. But there is a massive catch, and it loops directly back to our tectonic history. We mentioned iron.
Right.
In the gemological world, iron is known as a quencher.
A quencher, meaning it kills the fluorescence.
Entirely. If iron atoms are present in that crystal lattice alongside the chromium, the physics completely change. Iron is incredibly efficient at absorbing UV energy.
Oh, I see.
Yeah, if a UV photon enters the stone, the iron absorbs it before the chromium can even react. The energy dissipates as microscopic heat within the lattice rather than being emitted as visible light.
So in a Thai ruby, which formed in that iron-rich basalt we talked about, the iron basically acts as a lightning rod. It grounds out all the UV energy so the chromium never gets a chance to glow.
That is a highly accurate way to look at it, actually. Thai rubies often contain iron concentrations exceeding 400 parts per million atomic. They can have a stunning deep red body color, but they only reflect light.
Because of the quenching.
Exactly. Because of the quenching, they can appear somewhat flat or overly dark in certain lighting.
But Mogok's chemistry flips that script completely. The lab reports in our source stack highlight a very specific chemical signature for these stones.
The chemical threshold for a true Mogok ruby is extraordinary. The iron content is typically well below 200 parts per million, and simultaneously, the chromium content is exceptionally high, often between 0.3 and 0.5 weight%.
Meaning, the ratio of chromium to iron is greater than 1. The chromium dominates the lattice.
By a wide margin. Because there is virtually no iron to intercept the UV light, the chromium fluorescence runs unchecked. The stone reacts intensely to natural daylight. It generates an internal fire. It looks like a burning coal because it isn't just passively reflecting its environment, it's an active light source.
The idea of a gemstone acting as a tiny, self-contained sun is mesmerizing.
It really is.
But the sources point out another piece to this optical puzzle, and honestly, this is where I have to push back a bit.
Okay, let's hear it.
Because the reports spend a lot of time detailing something called silk. They define this as rutile inclusions, microscopic needles of titanium dioxide trapped inside the ruby. But wait, isn't clarity the ultimate goal in gemstones? You're telling me that these tiny internal flaws, this silk, actually make the ruby more valuable?
It absolutely challenges conventional wisdom, especially if a buyer's primary experience is with the diamond market, where a flawless, internally completely clear stone is the ultimate prize.
Flawless is better.
Usually, but with Burmese rubies, absolute transparency is actually a detriment.
How can a flaw make a gem look better? That makes no sense.
Well, it comes down to how light behaves inside a faceted object. When a gem cutter shapes a stone, they arrange the facets at specific angles to bounce light back to the viewer's eye.
Sure.
But it's physically impossible to achieve total internal reflection across every single angle. Some facets will inevitably be too steep, and light will leak out the back or the sides of the stone.
And when light leaks out, that specific area of the stone just looks black to the viewer.
Exactly. Gemologists refer to those dark, light-leaking areas as extinction.
Oh.
Every faceted gemstone has extinction zones.
Okay, I follow.
Now imagine a ruby that is perfectly, flawlessly transparent with high chromium fluorescence. The red glow would be intense, but it would just pass straight through the clear crystal or leak out the back. You would see bright red flashes contrasting with harsh, dark extinction zones.
Oh, I see. So it's high contrast, but maybe a bit harsh or unbalanced.
Yeah.
So how does the silk change that?
The silk in a Mogok ruby doesn't form randomly. The titanium dioxide crystallizes in a highly organized, intersecting grid of microscopic needles.
Like a mesh.
Exactly like a microscopic mesh. When that intense fluorescent red light is generated inside the stone, it hits this grid. The rutile needles act as millions of tiny internal mirrors. They scatter the red light in every possible direction.
Oh, wow. I see the mechanics now. By scattering the light, it forces the red glow into areas of the stone where light wouldn't normally travel.
It physically pushes the fluorescence into the dark extinction zones. The silk acts as a diffuser. It takes the sharp directional light and softens it, spreading a glowing, velvety wash of color evenly across the entire face of the gem.
That is brilliant. It's the exact same principle as putting a frosted diffuser dome over a harsh photography strobe. It turns a blinding spotlight into a soft, glowing, omnidirectional light source.
And that resulting texture is just impossible to replicate. When you combine the low iron daytime fluorescence with the perfect density of light scattering silk, you get a visual effect that is so distinct, so overwhelming, that ancient cultures felt compelled to mythologize it.
Right.
They couldn't just call it red, they had to invent a completely new vocabulary.
Which transitions us perfectly from the realm of quantum physics into the messy, highly lucrative world of human commerce and lore.
Yeah.
Because this specific visual phenomenon is so distinct, the trade needed a way to identify it. And the journey of how we describe this color moves from ancient folklore directly into the uncompromising, sterile laboratories of modern Switzerland.
And the historical weight of this color really cannot be overstated. Long before we understood tectonic plates or UV fluorescence, these stones were intensely revered.
Yeah, the sources say ancient Sanskrit texts didn't just classify the ruby alongside other gems. They called it Ratnarash, which translates to the king of precious stones.
Exactly. And the historical records note that the reverence bordered on fanaticism. Ancient Burmese warriors literally believed these glowing red stones granted physical invulnerability.
Right. They would cut open their own flesh and insert the rubies under their skin before riding into battle, which is just wild.
It is wild. But the psychological impact of seeing a stone that glows like blood in the sunlight is profound, and that visceral connection to blood is exactly how the ultimate color grade got its name. The local miners in the Mogok Valley, the people pulling these stones from the mud, use the term kotwe.
Kotwe. And the sources translate that as the color of the first 2 drops of blood from a freshly killed pigeon.
Yes.
Though there's another variation that says it refers to the exact red of a pigeon's eye.
Right. There's some debate.
Either way, it is an incredibly aggressive, specific, and memorable image.
It is. And pigeon blood became the ultimate shorthand for perfection in the trade. But the problem is, for centuries, it was entirely subjective.
Yeah, just based on someone's opinion.
Exactly. It was a romantic term used by dealers to justify higher prices. What one merchant called pigeon blood, a buyer might dismiss as just dark pink or overly purple. There was zero scientific baseline.
It was essentially a gentleman's agreement based on eyeballing the stone in an outdoor market.
Which is an incredibly dangerous way to conduct business when the asset in question is worth millions of dollars. Fair point. So, as the global gemstone market modernized in the late 20th century, that reliance on subjective folklore became a major liability. Institutional buyers needed metrics. They needed standardization.
And that is where the Swiss laboratories stepped in to impose order on the chaos.
Precisely. In 1996, GRS Gem Research Swiss Lab made a pivotal move. They were among the first to formalize pigeon blood not as a poetic descriptor, but as a strict, scientifically measurable laboratory standard.
All right.
And over time, other elite institutions like the Gubelin Gem Lab and SSF adopted and harmonized their own stringent criteria.
So if a collector submits a ruby to SF in Basel today, what exact scientific thresholds must the stone cross to earn that coveted phrase on the final report?
Well, the grading is merciless.
Merciless.
Truly. First, the basic hue must be a pure, vivid red. It is allowed a very subtle blue or purplish secondary undertone, which actually helps give the red a deeper, richer appearance. But if there is even a hint of orange or brownish modifier, it fails immediately.
Wow. So the color saturation has to be absolute.
It must hit the highest tier of saturation, what the labs classify as vivid. But the color alone is not enough.
Right.
Tying directly back to our physics discussion, the labs place the stone under standardized ultraviolet light. To earn the pigeon blood designation, the stone must exhibit medium to strong red fluorescence.
Which acts as a proxy test for the chemistry. If it glows, it proves the chromium is high and the iron is nearly non-existent.
Exactly. The fluorescence requirement scientifically filters out almost all basalt-hosted rubies, but this brings up a massive, often very expensive misconception in the broader market.
Okay, what's that?
Pigeon blood is a color, saturation, and chemical grade. It is absolutely not a geographic origin.
This is a vital distinction for you listening to grasp, because historically, 95% of all pigeon blood rubies came from the Mogok or Mongsu deposits in Myanmar.
Right.
The lore is deeply tied to the Burmese mountains, so it's very easy to assume the term implies a Burmese origin.
And it is a dangerous assumption. Because the Earth is chaotic, you know? On very rare occasions, a ruby mined in Vietnam or even Mozambique will crystallize in a localized marble pocket or a low-iron environment.
Really?
Yes, and if that specific stone meets the strict color, saturation, and fluorescence metrics, GRS or Gubelin will issue a report grading it as Pigeon Blood, despite it never having been near Myanmar.
So the chemistry dictates the grade, not the passport.
Exactly.
But the source materials highlight another wrinkle in this laboratory landscape that seems incredibly confusing for the consumer. The GIA, the Gemological Institute of America, which most people know as the absolute gold standard for diamond grading. Well, they don't use the term pigeon blood at all.
No, they don't. The GIA takes a strictly purist, scientific approach to nomenclature. They view terms like pigeon blood or cornflower blue for sapphires as trade folklore, not scientific classifications.
Okay.
If you submit the finest Mogok ruby on Earth to the GIA, their report will simply state the color is vivid red.
So what does this all mean for the listener? If I have a GIE report saying my ruby is from Burma and vivid red, does that automatically make it pigeon blood to a collector?
The market absolutely does not view it that way, and assuming it does is a six-figure mistake.
Wow.
The GIA is universally respected for determining a stone's geographic origin and confirming whether it has been artificially treated. But in the ultra-high-end collector market, the specific words pigeon blood carry an immense financial premium.
Right.
Without a supplementary appendix report from SF, Gubelin, or GRS explicitly stating that trade term, a seller cannot demand peak market value.
So the paper is literally as important as the physics. You are buying the Swiss consensus just as much as you are buying the Burmese crystal.
You're buying the liquidity that the paperwork guarantees. A buyer in Geneva and a buyer in Hong Kong might argue over what their own eyes see, but they will both accept a Gubelin pigeon blood appendix without hesitation.
Which perfectly sets up the next massive differentiator in value. We have spent all this time establishing the perfect chemical and optical baseline. But how a ruby achieves that perfection, whether it happened organically deep in the earth or whether it had a little technological help from humans, creates a valuation chasm that is almost difficult to believe.
It really is. This is the dividing line between commercial jewelry and investment-grade financial assets. And to understand the chasm, we must understand the mechanics and history of heat treatment.
Now, when people hear treatment, they often assume it's a modern scam or some shady laboratory trick. But heating rubies is practically an ancient art, isn't it?
It goes back centuries. Historically, miners in Sri Lanka and Myanmar would pack rubies into clay crucibles and heat them over charcoal fires using blowpipes to increase the temperature.
That's incredible.
Yeah. Today, it's done in sophisticated electric furnaces, but the goal remains identical. Heat treatment is a fully legitimate, universally accepted, and legally disclosed practice in the global gem trade.
And the sources estimate that roughly 95% of all rubies sold commercially today have been heat treated. So what is the heat actually doing to the stone on a microscopic level?
It acts as a continuation of the Earth's geological processes, basically. When you expose a ruby to extreme sustained heat, often upwards of 1,500 degrees Celsius, you can physically alter its internal structure. Remember the rutile silk we discussed? The titanium dioxide needles?
The diffusers that spread the glow.
Right. But sometimes the stone is mined with far too much silk. It looks cloudy, milky, or opaque.
Okay, too much of a good thing.
Exactly. So high heat literally melts and dissolves those titanium needles back into the crystal lattice. This dramatically improves the transparency of a cloudy stone. Furthermore, heat can alter the oxidation state of trace impurities, effectively burning off unwanted brownish or bluish tints, resulting in a purer red.
So human intervention can take a chemically flawed, cloudy piece of corundum and transform it into a beautiful, vivid, red gem. That seems like a net positive for the world. I mean, it makes beautiful jewelry accessible.
Oh, it is a massive positive for the jewelry industry. It allows a steady supply of beautiful stones to reach the consumer market. But from an investment perspective, heat treatment sets a baseline. It's common, it's reproducible.
Right.
The true anomaly, the geological unicorn, is the stone that comes out of the earth requiring no human intervention whatsoever.
The unheated status, the 1% of the 1%.
Less than 1% of all gem-quality rubies possess the perfect native chromium to iron ratio and the perfectly distributed, unaltered silk to look spectacular the moment they are washed out of the gravel.
Wow.
And when a gemologist at SSF looks through a microscope, sees the intact, crystalline structure of the silk proving it has never been subjected to a furnace and prints no indications of heating on the certificate, the valuation metrics completely detach from the commercial market.
You know, this is like the classic car market. A perfectly restored vintage car is beautiful and valuable, but a survivor car, with its flawless original paint from the factory, is a unicorn that billionaires fight over. The untouched provenance is what drives the frenzy.
That psychology translates perfectly to the ruby market, but with even more aggressive economic multipliers. What's fascinating here is how it affects the bottom line. If you place two Burmese rubies side by side on a table, same carat weight, same vivid red color, same clarity, but one is heated and the other is certified unheated, the unheated stone will command a premium of 2 to 4 times the price of the heated one.
Simply for being a survivor of the Earth's chaotic process.
Exactly. In specific sizes, we see 150 to 300% premiums purely for the unheated status. It is the ultimate flex of natural scarcity.
Let's dig into the 2026 evaluation reports provided in our sources and map out what this scarcity actually costs. Because ruby pricing, much like diamonds, is exponential, not linear. A 2-carat stone does not cost twice as much as a 1-carat stone. It costs vastly more because large, flawless crystals are exponentially rarer in nature.
And we must factor in the physical density of the mineral, too. Corundum is significantly denser than a diamond. A 1-carat ruby is physically smaller in visual dimensions than a 1-carat diamond.
Oh, that makes sense.
So finding a rough ruby crystal large enough to yield a 5-carat finished gem without heavy inclusions is a statistical miracle. Let's look at the 2026 pricing milestones for unheated investment-grade Mogok rubies.
Okay, let's start at the entry point for a serious collector, the 1-carat mark.
Right. For a single-carat, unheated Mogok ruby of fine color and clarity, the 2026 market dictates a price between $12,000 and $25,000.
Up to $25,000 for a stone smaller than a standard engagement ring diamond.
Yeah.
But then we jump to what the reports call the sweet spot, the 2 to 3 carat range.
At 2 to 3 carats, scarcity violently outpaces supply. The price jumps dramatically. You are looking at between $40,000 and $120,000 per carat.
Wow. So a top-tier 3-carat unheated Mogok ruby could easily demand well over $250,000.
Easily. But it's the 5-carat plus category where the pricing becomes just atmospheric. These are classified as museum-grade assets.
Right.
Depending on the specific provenance, the exact hue, and the distribution of the silk, a 5-carat unheated Mogok Pigeon Blood ruby commands anywhere from $300,000 to over $1 million per carat.
A $5 million stone you could accidentally swallow. The concentration of wealth is staggering. But earlier we teased a 10x multiplier. How does that factor into these numbers?
Well, the 10x multiplier represents the origin premium. If you take that unheated Mogok ruby and compare it to a chemically similar unheated ruby from Madagascar, the Mogok stone trades at a 5x to 5.5x multiplier simply because of the Burmese pedigree and the specific nature of its silk. But when you compare the unheated Mogok ruby to the secondary market standard, a heated Thai or Cambodian ruby, the Mogok stone commands a massive 10x economic multiplier.
It is a total dominance of the market. But abstract numbers on a 2026 valuation report only tell half the story.
True.
To see what happens when limitless capital meets finite geology, we must look at the absolute highest echelons of the global auction market. Because this is where the historical weight of the Mogok premium is forced to defend its crown against massive new challengers. We need to talk about the market titans, the Sunrise Ruby versus the Estrella de Fura.
Oh, these two stones provide the ultimate case study for everything we have dissected today: geology, physics, lab reports, and human psychology.
Let's examine the reigning champion first, the Sunrise Ruby. In May of 2015, this stone anchored a Sotheby's auction in Geneva.
Right, and the specifications on this stone are almost mythical. It is a 25.59 carat, unheated Burmese Pigeon Blood ruby.
25.5 carats. To survive the tectonic crush, avoid the iron, absorb the chromium, and retain that size after cutting. It completely defies probability.
It is a geological masterpiece. It was set into a ring by Cartier, flanked by massive diamonds. The atmosphere in that Geneva auction room was historic. The hammer finally fell at over $30 million.
$30 million for a single stone. If we do the math, that breaks down to approximately $1.26 million per carat.
It shattered records. It established the absolute ceiling for colored gemstones, becoming the most expensive ruby and the most expensive colored gemstone ever sold at auction at that time.
Wow.
It proved that the market would pay over $1 million a carat for the perfect Mogok singularity.
The absolute peak of the mountain.
Yeah.
But in the gem world, new discoveries are always lurking, right? Fast forward 8 years to 2023, and a massive challenger appears from a completely different continent. We meet the Estrella de Fura.
Yes. The Australida fura is a titan. It was unearthed in the Montepus region of Mozambique, which has become the most prolific ruby-producing region of the 21st century.
Okay.
The rough crystal was enormous, and after cutting, the finished gem weighs a staggering 52.22 carats. Note that some reports track it at 55.22 carats, but regardless of the exact fraction, it is more than double the weight of the sunrise ruby.
It's an unheated, breathtakingly red stone. And it went up for auction in New York in 2023, selling for nearly $35 million.
It holds the current record for the highest total price paid for a ruby. But we have to look past the headline number and analyze the per carat delta, because that is where the true market sentiment is revealed.
And this is the fascinating part. The Mozambique stone is double the weight, yet it only sold for a few million more in total. The per carat value is roughly half of the sunrise ruby. It sits at around $630,000 per carat, compared to the sunrise's $1.26 million.
Yeah.
So if the Mozambique stone is cleaner, bigger, and traceably mined, why does the market still pay double per carat for the hazy, silky Burmese stone?
It is the ultimate collision of optical physics and historical lore. Let's look at the physics first. While the Montepus deposits in Mozambique produce phenomenally clean, large crystals with vivid red color, their geological formation is different. They generally have a higher iron content than Mogok stones.
The quencher returns.
Exactly. Because of that higher iron, the Mozambique stones generally lack the intense high fluorescence Mogok glow. Furthermore, they don't possess the same dense network of rutile silk.
Okay, so the physics explain it.
Right, so while the Australida fura is incredibly transparent and glassy, it reflects light rather than diffusing an internal fire.
So the Mozambique stone is the choice for what we might call modern luxury. It satisfies the diamond buyer's aesthetic. It's huge, flawlessly clean and bright red. But the sunrise ruby represents generational wealth preservation.
That is the exact dividing line. The market pays double for the sunrise ruby because you are not just buying a flawless red lattice, you are buying the historical weight of 1,000 years of lore.
Wow.
You're buying the geological singularity that cannot be engineered or replicated by a modern mining conglomerate in Africa. The market dictates that absolute size and clarity are subordinate to the fluorescent glow and the Burmese pedigree.
Which brings a certain urgency to our discussion today. Because the astronomical value of these Mogok rubies isn't just a static reflection of history.
No, it's not.
The 2026 reports highlight that this value is currently being violently driven upward by a modern, multifaceted supply crisis. The market is experiencing a historic squeeze.
And the analytical term being used across the valuation reports is the valley of depletion.
Okay, explain that.
To understand this, we have to look at how Mogok has been mined. For over a millennium, miners have relied on secondary deposits. They were pulling rubies out of the shallow alluvial river gravels of the valley. The erosion of the mountains washed the gems down into the mud. You could literally pan for them, much like the gold rush.
Right, but 1,000 years of continuous panning will eventually empty any riverbed.
And that is exactly what has happened. As of 2026, those easily accessible, shallow alluvial deposits are virtually exhausted. The easy stones are gone.
So what do they do?
To find new production, the mining operations have been forced to shift to primary hard rock deposits deep underground.
They're having to trace the marble veins directly into the earth.
Yes. They are tunneling 150 meters or more down into the host rock, utilizing heavy machinery and explosives. This drastically increases the capital expenditure required to mine, while simultaneously drastically reducing the sheer volume of output. The river of rubies has been reduced to an agonizing trickle.
But geological depletion is only half the crisis.
Right.
We have to factor in the geopolitical reality of Myanmar. The political instability under the current regime, coupled with severe international sanctions, has essentially severed the supply chain.
It has.
And I want to be incredibly clear here for the listener. We are not taking political sides regarding the sanctions or the regime's actions. We are strictly analyzing the economic reality detailed in our financial sources. And that reality is a completely halted legal market.
The isolation is absolute. The sources document recent instances where massive world-class rough ruby stones weighing thousands of carats have been discovered in Myanmar.
Wow.
But because they were unearthed under the purview of the current sanction regime, they are classified as blocked assets. They cannot legally cross international borders. They cannot be graded by the Swiss labs. They certainly cannot cross the auction blocks in Geneva, London, or New York.
Here's where it gets really interesting. The international sanctions were designed to punish and economically isolate the regime. But by cutting off the global supply of new stones, the sanctions have acted as a massive price floor for the legacy stones.
Hmm.
The Mogok rubies that were exported decades ago and are already sitting in private collections in Europe, Asia, and America. The sanctions made the collectors exponentially wealthier.
It's a textbook, inescapable supply and demand shock. You have a surging global demand for hard assets from institutional wealth, but they are forced to compete for a finite, closed pool of legacy stones. There is zero new supply entering the legal market to relieve the price pressure.
And financial metrics reflect that panic. Looking at the data between 2016 and 2026, unheated rubies have demonstrated a compound annual growth rate, or CGR, of 9.4%.
A 9.4% sustained annual growth rate over a decade is a phenomenal metric for a physical asset. It means unheated rubies are aggressively outperforming traditional safe haven assets like gold bullion.
That's incredible.
They're vastly outperforming colorless diamonds, which have faced their own market challenges. In specific high-end categories, these rubies are even pacing ahead of the S&P 500 index.
Now, you mentioned the challenges facing colorless diamonds, which inevitably brings up the technology question. We have watched lab-grown diamonds completely upend and crash the commercial white diamond market over the last 5 years.
We have.
Consumers realized a lab diamond is physically identical to a mined diamond, but 90% cheaper. Why hasn't a lab-grown ruby crashed the Mogok market in the same way? A laboratory can easily synthesize red corundum.
They can synthesize it very cheaply, but they cannot synthesize the history. And they struggle to synthesize the flaw. The 2026 market reports are definitive. Lab-grown rubies have had absolutely zero impact on the pricing of investment-grade natural rubies.
Why? If a lab can dial in the exact chromium to iron ratio to mimic the glow, why does the billionaire still pay $1 million a carat?
Because a lab-grown ruby is too perfect. It grows in a sterile, controlled environment in a matter of weeks. It looks like perfectly clear red glass. It lacks the complex, chaotic, internal fingerprint of a natural stone.
Right.
It lacks the dense, specifically oriented rutile silk that grew under unimaginable tectonic pressure over millions of years. When you look at a lab ruby, you see human engineering. When you look at an unheated Mogok ruby, you see the violent history of the Earth. The high-end market doesn't pay for perfection, it pays for unrepeatable provenance.
That distinction forces us to really examine how we define true value in 2026. The Mogok ruby isn't just a shiny red rock. It represents a physical and historical singularity. It is the impossible sequential convergence of the Himalayan tectonic plates crashing together, the burial and baking of pure oceanic limestone into an iron-free marble sanctuary, the blind injection of chromium-rich magmatic fluids, and 1,000 years of cultural mythos stretching from ancient blood-sworn warriors to modern Swiss laboratories and Manhattan auction houses.
Exactly.
You simply cannot manufacture that narrative in a vacuum chamber.
And this raises an important question, right? That narrative, backed by the undeniable optical physics of the stone itself, is the essence of why it has been crowned the ultimate hard asset of the decade. Its value is anchored in a chaotic, fundamentally unrepeatable history that no amount of modern capital or technology can replicate.
We have covered incredible ground today. We started 50 million years ago in the crushing depths of a lost ocean. We explored the quantum mechanics of chromium fluorescence and how microscopic mirrors of titanium silk diffuse light.
Yeah, it's been a ride.
We navigated the strict, unforgiving parameters of the Pigeon Blood designation and the massive economic chasm between heated and untouched stones. And we climbed all the way to the multi-million-dollar auction blocks of a market currently gripped by a historic, geopolitically driven supply squeeze.
It is a journey that connects deep geological time directly to acute modern economics. But as we look at the rapid advancement of technology, it leaves us with one final, deeply provocative question to consider.
What happens when the technology finally catches up to the Earth?
Exactly. Let us imagine a future, perhaps only a few decades away, where a laboratory eventually learns to perfectly replicate not just the basic corundum chemistry, but the exact chaos of nature.
Yeah.
Imagine a machine that can perfectly print, atom by atom, the low iron, high chromium, rutile silk-included structure of a Mogok ruby, a stone that can fool the microscopes at SF, a perfect, indistinguishable clone of the Earth's greatest accident.
If we reach a point where we can hit a button and print geological perfection, does the billion-year struggle of the Himalayas still matter to our definition of value? Or is human desire permanently, inextricably anchored to the romance and the absolute rarity of the Earth's authentic history.
It is a question that goes far beyond gemology, striking at the core of why we collect anything at all.
And is the perfect thought to leave you with. Thank you so much for joining us on this deep dive into the world's most coveted gemstone. We hope this exploration has shed some light on the hidden, glowing depths of the world around you, and we warmly invite you to keep learning, keep questioning, and keep exploring the incredible anomalies our planet has to offer. Until next time.